Good morning, 7th grade. It is Monday, April 20th, and we are on lesson 102 today. 102 today. So, we're going to talk about two things that are totally different from each other. And we're going to start by talking about transversals. Now, what is a transversal? Well, trans means across, okay? So, what we're going to do is we're going to take two parallel lines. I've got two parallel lines I'm going to draw here. And a transversal is just a third line that is going to go across and intersect both of those lines, parallel lines. And we're going to create 8 angles, 8 angles. So I'm going to call this angle 1, 2, 3, 4, 5, 6, 7, and 8. Now, here are 4 different types of angles that are created with this transversal across these two parallel lines. Now, we've talked about vertical angles before. Vertical angles are angles that are opposite each other when two lines intersect. So angle 1 and 4 are vertical angles. So I'm going to write that pair. I've got 1 and 4 are vertical angles. Now let's do another pair of vertical angles. Look right here. 2 and 3. 2 and 3 are vertical angles. Let's go down to the bottom set. I've got 5 and 8. You see that? 5 and 8 are across from each other. They are vertical. So I've got 5 and 8. And then I've got another pair, don't I? I have 6 and 7. And vertical angles are congruent. So 1 and 4 are the exact same measurement. 2 and 3 are the same measurement, and so on and so forth. All of these pairs are congruent with each other, 1 and 4, okay, are congruent. Now, 1 and 4 aren't the same as 2 and 3, but the pair themselves, the pair have the same measurement. Now, let's go to corresponding angles. Corresponding angles are angles in the top section and the bottom section that are on the same side of the transversal and in the same position above or below the parallel line. Now, what do I mean by that? Okay, well, let's look at angle number 1. Okay, it's to the left of the transversal and it's above this parallel line. So angle 1 corresponds to angle 5 on the bottom here. It's to the left and above its parallel line. So corresponding angles are 1 and 5. And corresponding angles have the same measure. Now let's go ahead and look at another pair that correspond from the top 4 and the bottom 4. So here's angle 2. What does it correspond to? Well, it's to the right of the transversal and above the parallel line, and so is angle 6 in the bottom set of angles. And so 2 and 6 correspond. Let's go ahead and erase those lines, and let's go to angle 3. Well, angle 3 corresponds with angle 7. So I'm going to put 3 and 7 correspond. And then finally, what am I left with? 4 and 8. 4 and 8 are both to the right and below. So 4 and 8. And these pairs are going to have the same angle measurement also. Now, alternate interior angles. Now, interior paint is used to paint the inside of a house. So when we talk about interior angles, we're talking about these 4 angles here that are between the parallel lines. Interior, inside the parallel lines. Now, alternate means on opposite sides of the transversal. So let's go ahead and look at that. We know we've identified our 4 interior angles. Now, for them to be alternate, they have to be on opposite sides of the transversal line. So 3 is an alternate interior angle with angle 6. They're both interior angles, but they are on alternate sides or opposite sides of the transversal line. So my alternate interior angles are 3 and 6, and they'll have the same measure. And then my other alternate pair are 4 and 5. So I've got a 4 and a 5 here. Now those are alternate interior. I think you can guess what my exterior angles are. My exterior paint is going to be painting the outside of my house. And so angles 1 and 2 and 7 and 8 are really outside of the parallel lines. You want to think about it that way, okay? inside the parallel lines, outside. Okay, so 1, 2, 7, and 8 are my exterior angles. Well, alternate again. 1 is on the left side of the transversal. 8 is on the right side. So 1 and 8 are called alternate exterior. And then that means that, let's erase this, 2 and 7. 2 and 7 will be my other pair of alternate exterior. And those are congruent also. 2 and 7 are acute. 1 and 8 are obtuse. By the way, let's just circle all the obtuse angles. Obtuse, 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 obtuse. All of those obtuse angles are going to have the same measurement, okay? And then here are my acute angles, 2, 3, 6, and 7. And all of those are going to have the same acute measurement. So, all right. And what else do I know? The obtuse and the acute are supplementary. They will add up to 180. So 1 plus 2 adds up to 180. 3 and 4 adds up to 180. Actually, 2 and 4 adds up to 182. So every acute and obtuse angle in this setup adds up to 180. Now, let's just leave that behind now. We'll talk about that on the homework in just a second. And now we're going to talk about something totally different. We're going to be at the end of the road today, guys, on solving equations with algebra. This is the end of, this is as complex as it's going to get today, okay? But this is a really critical day today. This is very important in being able to solve equations. And let me slide this over just a little bit, okay? Now, whoa, I see a lot more terms than I usually see here in a normal equation. I've got 3x plus 5 minus x all on one side, whoa. And I've got 17 plus x minus x on the other side. Now, let me tell you, every time you solve these equations, what you're going to make sure you do is on each side, just make this equal sign like a wall. On this left side, you've got to combine like terms, so you only have one variable term and one constant term, the constant being the plain number, okay? So just don't worry about the other side of the equation. We're going to focus right now on 3x plus 5 minus x. Now, do I have like terms here? You betcha. I've got a 3x minus 1x. I have to combine those before I can go any further. So 3x minus 1x is 2x. And I have 2x plus 5 on this side. Now I'm going to put my equal sign. Now I'm just going to focus on the right side. I have 17, and then I have a plus x and a minus x. Well, what is 1x minus 1x? 0 x's. And so I end up with a 17 here. Okay, this is a two-step equation, which we learned how to do right when we started online learning, okay? Now, what do? I look on the side with the variable. I always add or subtract first. I'm going to subtract 5 from both sides of my equation. I'm going to bring down my 2x. 5 minus 5 cancels. 17 minus 5 is 12. I'm going to divide both sides by 2 to isolate the variable. X equals 6. Now, if you were to plug 6 back into this complex fraction, equation up here, it would be a true statement. And I've got some other examples, so I'm not going to take the time to do it, but you can always plug this number in and make sure that it makes both sides of the equation true. Now, let's go ahead, and it's going to get a little bit more interesting on this side. Okay, now, let's look over here. This is something different. Now, I have an x term and a plain number, and on this side, I have an x term and a plain number. I don't have anything to combine on this side. There's no like terms to combine. I look on this side. There's no like terms to combine. So I don't have to do that. But what I'm going to do is I've got to isolate my variable by doing something we've never done before. And I'm going to put it down here. I'm going to go to step 3 here. We're going to isolate the variable by first moving all the variables to one side. And then we're going to move all the constants to the other side. Okay, now don't worry about these first two right here. We're going to get to those when we get to this equation over here. But for right now, when you have variable terms on both sides of the equal sign, you have got to first move your variable term. Now, I always say, okay, 2x is on this side. I'm going to move it to this side. You never divide or multiply to move a variable term. You're always going to add or subtract. Now here, what is the opposite of adding 2x? Subtracting 2x. So I'm going to put a minus 2x on both sides of my equation. Okay. Now, I want to bring this to your attention because I have students do this all the time. Okay? You see this, what we did here? Some students will just say, I'm going to put a plus x here and a plus x here. Don't do that, okay? You're not adding, you're just, on this example, you're just combining like terms. 3x minus x is 2x. Don't right here, you never want to add x's or subtract x's from the same side of the equation. So let's look over on this side again, okay? We are simply going to this time, because we have x's on both sides, we're not combining like terms, we're moving the x from one side to the other. Now, what do we have here? 5x minus 2x is 3x minus 17 equals. Well, 2x minus 2x, that's going to cancel out, and I'm going to bring down a minus 5. Okay. Now, next thing I'm going to do is move my constant. Well, we know how to do that. This is our two-stepper, isn't it? So now what am I going to do? I'm going to move the constant to this right side. I moved the variable 2x to the left side with subtraction. Now I'm going to use addition to move the 17 away from the variable. So I have 3x equals, okay, what is negative 5 plus 17? It's the same thing as 17 minus 5. It is a positive 12. And so I have a 12 here. I'm going to divide both sides by 3. X equals 4. So what I did here, I did not combine like terms on one side of the equation or the other. I simply saw I had variables on both sides of the equal sign. So I had to move my x terms to the left, and then I had to move my constant term to the right. Okay, now look at this one. This one is the great poobah of all equations you have to do this year. And there's a new step, and that is we have parentheses. So you're going to have to eliminate parentheses. You're going to have to eliminate parentheses using the distributive property for your very first step if you ever see parentheses. So I've got 3x. Now, I've got positive 2 is going to be multiplied by x to give me a plus 2x. I'm going to go back and distribute by multiplying positive 2x times negative 4 to give me a negative 8. I've done the distributive property. I'm going to put equals 32, and I have eliminated parentheses first step. Okay. Now, let's combine like terms if we need to on one side of the equation. Oh, look over here. I have 2x terms on the left side. 5x is the sum of 3x plus 2x. So I have 5x minus 8 equals 32. All righty. Now, I really didn't need to move. I didn't have x's on both sides of my, I don't have x's on both sides. So I don't have to take an x here and move it over here like I did here. Move it over, okay? Here, I'm just going to go ahead and isolate my variable by first adding 8 to both sides. So here's my two-step, plus 8, plus 8. Excuse me, 5x equals what? 40. Divide by 5, x equals 8. Okay, there we go. Now, let's go to the homework. Let's go to the homework. Okay, now I'm going to go ahead and erase this because I didn't have enough room to put the homework problems on there today. But the homework problem, first we're going to do is number 16. Okay, so I'm going to do 4 homework problems with you today. So we're going to spend a little bit more time together today, but that gives you less to have to do yourself. Okay, now number 16. Number 16, here we go. All right, now I have 2 parallel lines. Sorry, my back is to you right now. And I've got a transversal. And they are, instead of numbering 1, 2, 3, 4, it's A, B, C, D, E, F, G, H. I hope you have your your homework worksheet right now because we're going to be doing number 16. So make sure you got that out. Now, letter A. What angle corresponds to angle C? Okay, corresponds means it's going to be an angle in the bottom group of 4 angles that's on the same side and in the same location relative to the parallel line below. So C is to the left of the transversal, and it's below the parallel line. So my corresponding angle down below is going to be the left of the transversal and below the parallel line, angle G. Angle G. Okay, let's go to B. What does B say? B says, which angle is the alternate interior angle of angle E? Okay, now we're going to talk about interior angles. Here's angle E. It's an interior angle. C, D, E, and F are all interior. What's the alternate interior angle to angle E? Well, alternate means it's going to be in the alternate or opposite side, and it's going to be alternate interior. Okay, so here E is going to be an alternate interior to D. Alternate interior on the opposite side, but this one's going to be, see, this is obtuse, it's going to be other obtuse to the right side. So it's angle D. Alternate interior. Alternate side, and then it's going to be one of these upper ones. So E and D. Okay, let's go to C. C says, which angle is an alternate exterior angle to H? So now let's look at H. I'm going to give H 2 lines here. Alternate exterior. Alternate exterior. Well, I'm going to go up to the top group here. Alternate across and exterior would be A. So angle A is an alternate exterior. And then D says, if the measure of angle A is 110 degrees, okay, what is the measure of angle F? Now, angle A is one of my many obtuse angles. Every obtuse angle is going to be 110 degrees. And F is the acute angle. So they're always supplementary. So what's 180 minus 110? Will give me the measure of F, okay? It's supplementary to this, and so 180 minus 110, 70 degrees. 70 degrees. And there you have it. There you have it. Okay, now let's move on to number 25. Let's go to number 25. I'm going to write it out right here, number 25. So go to that number on your worksheet. I've got 3x plus 3 to the 0 equals 49. And I am supposed to solve this for x. Okay, now I don't have any parentheses, so I'm going to skip that step. Okay, next step is, can I combine like terms on one side of the equation? Absolutely. Look over here. I've got 3x plus 1x. Well, what's that? Let's all write that down. That's 4x. What's 3 to the 0 power? 0 or 1? It's 1. Let's put a 1. Equals 49. Okay. Two-step equation. You should be good at these by now. Okay. I'm going to first go on the side of the variable and first add or subtract. I'm going to subtract 1. I'm going to bring down 4x equals 48. I'm going to do what? Divide both sides by 4. X equals 12. Boom. Solve the first one. All right. Let's go to number 26. Let me erase this, and we'll do number 26. Go ahead and write it down. We always write down our original equation on our work. Number 26 is 3y plus 2 is equal to y plus 32. Okay, I don't see any parentheses to get rid of with the distributive property. I do not see that I need to combine like terms like I did here. On this side, I had to combine like terms. This side doesn't have any like terms to combine, and neither does this side. So I go to the next step. And the next step is, do I have variables on opposite sides of the equation? I do. And I'm going to move those variables, any variables I have on both sides, I'm going to move them to one side. I always move them to the left side, okay? So, okay, I got a y here. Well, you never multiply or divide. You always add or subtract. So let's go ahead. What's the opposite of a plus y? A minus y. So I'm going to put a minus y on both sides, draw my line all the way across. And I'm going to and notice my y terms have to go underneath my y terms. Don't put the y under the 2. I should have mentioned that earlier, okay? All right, 3y minus 1y is 2y. 2y plus 2 equals, well, those are gone, 32. What have I got here? Two-step equation. Go to the side with the variable. Add or subtract first. Bring down 2y. 2 minus 2 goes away. 32 minus 2 is 30. Divide both sides by 2. Y equals 15. We are done. We have one more to go. You've been hanging with me. I appreciate it. Number 27. Let's write that one down. I bet this is going to have parentheses in it. I feel it. I sense it. I am correct. Okay. So number 27 is x plus 2 times x plus 3 equals 36. Okay. Now, first step, eliminate parentheses using the distributive property. Okay. Now I'm going to write the x right here. Now I have a positive 2 times x. Well, 2 times x is a positive 2x. Now let's go back. I have 2x times positive 3. Well, 2x times a positive 3, 2 times 3 is a positive 6. You must put the plus or minus sign, okay? Now, equals 36. All right. Now, step 2. Do I have like terms to combine on one side of the equation? Oh, look, I'm right there. Yes, I do. Yes, I do. I have x plus 2x. X plus 2x is 3x plus 6 equals 36. Aha! I'm down to my 2 steps. Go to the side with the variable. Always add or subtract first. I'm going to subtract 6. From both sides, draw your line all the way across. 3x equals 30. Divide both sides by 3. X equals 10. All right. So there are my 3 equations from homework today. And we did the transversal. So we've done 4 equations. And look at the omissions today. Oh my word. Okay. 1, 5, 10, 12, 14, 17, 18, 21, 24. That's 9. Plus the 4 I did is 13. This is amazing. You only have 17 more problems to do, and I knocked out the really hard ones, okay? Now, I hope you've heard that we are not going to be doing a new lesson on Friday, but I am going to go ahead and have the Khan Academy still do Friday at midnight, okay? I haven't picked it out yet, but I will have it done by the time you watch this video. So you'll have a couple of Khan Academies to do by midnight on Friday night. And this homework will be due Tuesday morning at 9 a.m. Uploaded work on the correct page in LMS and entered into My Math Assistant. All of these omissions should be a little yellow box, needs help. Okay, everything else should be green or red. Most of you have been doing great with that. Okay, so have a blessed Monday, and I will see you at Zoom today at 1 or 2 o'clock, or I will talk to you again on Tuesday morning. Have a blessed day. Bye-bye.